Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is another in my practice session series for the Red Hat Certified Specialist in Linux Diagnostic and Troubleshooting Exam EX342. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed, to click that subscribe button. Also, a reminder that these are my final review sessions for the exam. I'm going through the posted objectives, and I'm trying to either explain the concept behind the objective or do some exercises to practice whatever the objective is asking of you. And at the end of the video, I'll do a little assessment and hopefully I'll feel confident with the objective. If not, I still have about a week and a half or so to do some final brushing up and filling in some knowledge gaps. So that being said, these should not be used as tutorials nor be considered authoritative information. I am learning right along with you, and I try to have the information accurate because hopefully at this point in my preparation I will, I know what I'm talking about, but because of that, these should not be used as tutorials or be considered authoritative. I put these out on the internet in hopes that those that are preparing for the exam might see some of the practice stuff that I do and get some ideas of exercises they can create for themselves to prepare for things. So continuing with the diagnose and troubleshoot file system issues, we're going to look at recover data from encrypted file systems. And this is about using LUKS and LUKS encryption. One thing I have enjoyed with the preparation for this exam is there's a lot of tools here that I don't get to use in just day-to-day administrative activities. The environment that I use just doesn't use them, or I haven't had particular applications that might need this type of infrastructure. So the exam, in addition to just validating some troubleshooting skills and frankly getting some ideas of how I can better manage my own production environments, it's exposed me to some nifty little tools. Now, LUKS, I am aware of. I haven't done a lot of administration with LUKS prior to preparing for this exam, but I just want to make a general comment to those. If you're thinking about taking this exam, the goal of any certification is to learn the skills, and then you take the cert, and if you pass the cert, hey, that's the added bonus. But the real value is the learning of new things and being exposed to some stuff, and this is a pretty good certification to do that, in my opinion. So I'm going to go into my lab server 5 because it's the one that I've attached another block device to, and let us become root. And what I'm going to do is, I guess I can just do the entire, I'll do the entire device. Now, the objective is recover data from encrypted file systems. So in my opinion, that implies that you will already have some encrypted file system, and you are going to be trying to get the data back from it. So when you're trying to prepare for this, I think it's helpful, and we'll see how well I remember how to do it. I think it's helpful to learn how to do the thing rather than just try to memorize commands and such to recover from problems, because when you're doing the thing and you break it as you're doing it, I think you learn a bit more about what's going on and you kind of understand what's happening underneath. So let's see how well I can do this. So what I'm going to do is, I think crypt setup is already, I guess crypt setup is not on this. Which crypt setup? Oh, it is. Okay. I must have been misspelling it. All right. I believe what I want is LUKS format. Let's see if I'm right with this. So crypt, there's LUKS 1 and LUKS 2. Differences in capabilities with which I think 2 is backwards compatible with 1, but I'm fairly sure we're going to be using LUKS 2 with this. That's the current thing. Oh yeah. All right. YPT setup. We're going to do LUKS format. And the device is going to be dev VDB. And I wonder if I already have to give it the name that the dev mapper system, or I guess DM is the actual, the device mapper system is going to use for this. So let's just call it test encrypt. It's going to warn us that it's going to overwrite all the data, and that is okay. Oh, I have to do it in capital letters. Is it LUKS-create then? Let's try LUKS-create. I guess LUKS-create's not a thing. All right, when in doubt, let's say that on the exam I have to create an encrypted file system, which I don't think that'll be the case. I think it'll be something's broken, we have to fix it. But man crypt, I cannot spell crypt tonight. Right? Okay, so we want to use LUKS, open and close, I'm aware of that. I don't think re-encrypt is the right thing. Create is like, I guess, the standard DM stuff. We want the LUKS-2 commands. LUKS format didn't do what I wanted. You know, I'll bet if I had set up a key file, LUKS open, add key, remove key, change key, not doing any of that. Well, when in doubt, look at the examples, right? So I guess crypt setup, type LUKS-2, LUKS format. It's probably what I want. Okay, so let's see if I can do that. And we'll do dev vdb, and let's see what happens. This is what I was expecting to see. So we're going to give this a password. We'll do the monkey123 with a capital M for security. I'll have to do it again. Yep. Seriously? Okay, so let's try it again. I'm actually curious of the command I did before and how this is different. Oh, yeah. Now I understand. I did not need to put the device mapper name that it's going to go to. So that makes sense. Okay. Yes, and let's do monkey. What could I do that's secure? Let's do foo monkey 123. Foo monkey 123. Okay, so we have an encrypted device now. So at this point, if you lose foo monkey 123, you're sunk, because you have to have that to unencrypt the device. And what we can do here, I guess we make a file system of this. Make fs. Actually, we'll probably have to open this first. So crypt setup LUKS open dev vdb. Yep. And this is where we're going to give it its dev mapper name. So we'll call it test crypt. I have to put in the passphrase. So foo monkey 123. All right, so that's been opened up. If I look at ls-blk, we see test crypt. And you can do, what is it? DM setup ls type crypt, I think. Is it target crypt? Yeah. All right, so we can see that we actually have an opened up LUKS-encrypted thing when it sets the test crypt. So from here, we can make a file system. I'll do ext4 this time just to be different. And this will be dev mapper test crypt. Yay, and we're going to mount this. You know, there's a couple different things I can test here. All right, let's stay focused. Let's fix this first, and then we can deal with persistence. So we have our file system here. Let me let me mount it. Make a directory first. And let's mount dev mapper test crypt to mnt test crypt echo super secret to mount test crypt test.txt. Okay, we can cat that. Yay, all right, so we have an encrypted volume. So we can close this. So that would be crypt. Actually, I probably need to unmount that file system. And then we can do crypt setup LUKS close. Oh, we have to use the device mapper. Okay, so now if I do that DM setup ls target crypt, we shouldn't see anything there. Okay, so the options that you have as far as trying to recover something that's been encrypted, you have a couple of things. We can do, I think it's crypt setup LUKS dump dev vdb. Yeah, and this shows us we have one key slot 0, being used for a password. And I want to think that LUKS-2 supports, I think it's 32 maybe. That would be something that I'd want to look up. I don't think I necessarily have to know that for the exam, but just good general knowledge to have. And so what you could do, you could be in an environment where you can have a key added to this. Let's see if we can do that actually. Like you'd have a master key that's on everything, and you have that stored away in case someone has forgotten the other password. You can use the master key to unlock it. Let's see if we can do that. So crypt setup, I think this is going to be LUKS add, I misspelled crypt again, LUKS add key. It's going to be dev vdb, use an existing passphrase, so that's foo monkey 123. And we're going to add a new passphrase for a key slot. We'll just call it foo monkey 456. Of course, they didn't match. All right, let's try this again. Foo monkey 123 and foo monkey 456. Foo monkey 456. And this takes a bit because I think there's things that happen in the background as the LUKS header is being basically made anew. So if I were to do crypt setup LUKS dump dev vdb, we now see that we have 2 key slots used, one for each of the passwords. You're obviously not going to be able to see the password with this, but you'll know that there is another password available to be able to use. Now, let's see if we can back up the header without this being open. So, crypt setup LUKS header backup, and the device is going to be dev vdb, and I think it's header backup file. Yeah, so we're going to just store this in root crypt backup. Okay, good. It can grab that without actually needing to unencrypt the file. So this header backup has backed up what keys are available for using the or for unencrypting this LUKS-encrypted thing. Obviously, you're not going to be able to see the key in that backup, but the header that is configured for LUKS that contains the information that you feed it the key and stuff works, that is now in this backup file. So what I'm going to do is we're going to do crypt setup remove key dev vdb, and we're going to get rid of foo monkey 456, and we're also going to, let's see if I can do this. Thought there was a change key. Wait, CRYPT SETI setup. Look at the man page for that real quick. Thought there was a change key. Basically, I'm wanting to change the password. Or maybe it's re-encrypt. No, I don't think it's re-encrypt. I think that's like you truly blow away everything and start over. Or I may be wrong. Yeah, LUKS change key. That's what I thought. All right, so maybe it just wasn't doing autocomplete for me. LUKS change key dev vdb. Yep, and this is going to be foo monkey 123, and we're going to change this to Eddie 123. Really? My name is too simplistic. All right, so foo monkey 123, and we'll do foo monkey 789. Foo monkey 789. Okay, so I got rid of that one key. We've changed the password. So if I were to try to do crypt setup LUKS open, the VDB will open that to test crypt. And I try good old foo monkey 123. It's going to tell me that there are no available keys that match that particular passphrase. So, oops, didn't mean for that to happen happen. So at this point, you either, let's say that we have not messed with any of the other keys. That other key would be able to unencrypt this, but if we've lost both passwords, we're sunk unless we have the header that has been backed up. So what we can do to recover that, crypt setup, LUKS header restore the device, header backup file, root crypt backup. And it's going to ask us, are we sure? Because if we were to do the wrong header, then whatever, let's say you have multiple header backups, you do a header for which you don't remember the password to, then you're out of luck. So now we should be able to do crypt setup LUKS open dev VDB. We're going to do what do we call it? Crypt test. No, it was test crypt. I'm going to try foo monkey 456. That was the key that we just straight up deleted. And no errors. DM setup ls target crypt. And we see that it is there. At this point, we could add our mount to the etc/fs tab. We would be using the I haven't mounted that yet. We will be using the dev mapper, and I think you may be able to do. Is it here in block ID? Yeah, we could use the UUID as well. So what we're going to do is add this to etc/fs tab, test crypt ext4. We'll just use good old defaults. Mount -a, and we should have our mounted thing. Now, the problem here is if we were to reboot, then during the boot time, you're going to be prompted for a password to unencrypt the encrypted volume that this is on. Or actually, without this next thing I'm going to configure, it might not even ask you to do that. I am curious though. We're going to umount mnt test crypt and kind of simulate what a reboot might look like with the configuration exactly as it is. So we're going to do crypt setup LUKS close dev VDB. Oh, I have to do the test crypt. If we were to try to do mount -a, what's going to happen is it's going to complain that dev mapper test crypt does not exist. And it doesn't, because until LUKS has unlocked it and DM setup has done its thing, the dev mapper test crypt isn't going to be a thing. So the question becomes, all right, so how can we make this persistent? Because everything has to be persistent for these exams. There's a file called etc/crypttab. Oh, good, it's already there. And I'm actually going to do ls-l for that. I think it's 600, yeah. So within our etc/crypt tab, we basically have three columns. We have the name of the dev mapper device that we want to use, which is going to be test crypt. We have the actual device that's encrypted. And then this can either be a file that will contain the password, or in this case, for this example, I'm going to do none, which means it's going to prompt us for a password. So now if I were to do mount -a, I would expect it to ask me for a password. No, it doesn't. Okay. And that honestly makes sense, because mount's not going to know what to do with that. There is, when I was doing some practicing, I was able to kind of simulate the reboot process. Actually, what we'll do, let me bring up a console session for this. Let's see what happens when we do try to reboot. Okay, now that the console session is up, let us reboot and see what happens. What I'm expecting is that it's going to prompt us for a password, but I may be wrong with that. We'll see. Yep, enter passphrase. I'm not sure how visible that's going to be for you. So we can do foo monkey 123. and then it will finish booting. So let's take the console away. Let's go back into SSH for Lab Server 5, become root again. We see our file system. All right, so what we can do to not have to do that is set up a key file. Now, one gotcha that I found and had to use Dr. Google to figure out exactly what happened. Basically, a key file is just going to be a text file that has your password in it. So I could make a file vi crypt pass and put foo monkey 123 in it. This is actually going to fail because if I were to cat crypt pass, there is a new line character at the end of that. You obviously can't see it, but it's what allows the next line to not be attached to the text that was put in the standard out. Now, if you wanted to, you could have started with a pass file when we did the initial making of the initial encryption, where the new line would be a part of this. But since we haven't done that, we're going to do echo -n. I believe -n does no new line. Let's check that out real quick. Yeah, do not output the trailing new line. So echo -n foo monkey 123 into crypt pass. See the difference in the output there? That's without that new line. So what I can do is go into that etc_crypt tab file, and we can change this to the path that we want. And so now we should be able to, it will automatically unencrypt this when you have booted. I'm not 100% sure of the maybe usefulness of this on a VM. Well, maybe, when you power it off. Yeah, never mind. When you power it off, it'll be encrypted at rest. So that's probably the usefulness aspect of it. But anyway, let's bring back up that console once again, and I'll reboot, and let's see if it will finish booting without needing a password. Well, the fact it's stuck there does not look good, even though I can't imagine why that would affect getting to grub, unless there's some issue with my VM. All right, let me go into the hypervisor real quick and force a reset, and let's see what happens. All right, that looks better. Not quite sure what was going on there. That would be something worth troubleshooting. Not for this particular practice session, though. Okay, so it completed booting. We'll remove the console here from the video. And if I were to SSH back into Lab Server 5, we see our unencrypted file, dm setup ls target encrypt, and we see that that's there. So that's how you can make the unencrypting of your LUKS stuff persistent, which I have a feeling on the exam that's something that we're going to have to do. So looking at the objective, recover data from encrypted file systems. That's about it. I mean, you either have a backup password or you have a backup of that LUKS header, and you hope that you have the password that is associated with the LUKS header that has been backed up, and then you can do the restores of that. And then to make it be persistent, you have to work with the etc_crypt tab file. So I think for this this particular objective, I feel confident that I will be able to handle what's thrown to me on the exam related to this. So if you found the video useful, make sure you do click like. Also, I want to thank returning subscribers again for watching another video and encourage you to click that subscribe button if you're watching and you haven't subscribed. Thank you for taking the time to watch, and I'll see you the next time.